Hello my dear students, welcome back to NEET World. So in this session we will be discussing the previous year questions of JEE, NEET and EAPCET exams. Okay, so let's begin the session with first question. Here we have is the incorrect statement from the following for the borazine is. So identify the incorrect statement from the four options here. See, what is borazine first? It is also called as inorganic benzene. What is it? Inorganic benzene. Right now, B3N3H6 here. So something like isoelectronic with benzene ring. Right now, and you know here it has delocalization. Right now it has delocalization, but not as effective as in the benzene, because the electronegativity difference between boron and nitrogen here in the borazine, like you just write it like this. Yeah, you just take it like this first. Okay, now due to the presence of vacant orbital on each boron and lone pair electrons on nitrogen, okay, after having this, so now these lone pairs are donated from the nitrogen to boron, therefore we are going to get a double bond here, double bond character here. Okay, so between all this nitrogen and boron, what we have a double bond like this, like this. Okay, on each nitrogen we have one hydrogen atom. Okay, so like this, here nitrogen if I want to represent plus, and here I should represent minus, like this you have to represent. Okay, this is the structure of borazine. Okay, inorganic benzene we can say, and see the structure is similar to what? Benzene ring, right now? Yes. So now here look at this, it has electronic delocalization. Yes, it has weak electronic delocalization, but not as compared with the not like as the benzene ring, because of there is a large electronegativity difference between nitrogen and boron, right? That's why the electron delocalization very weak here, but it has. Okay, next, it contains banana bond. No, there is no banana bond. There all these bonds are direct bonds, like BH, two center 2 electron bonds only here. Nothing like banana bond that we have seen in the diboron concept. Right now diboron structure if you observe, it has banana bonds. I will explain in the next question what is the banana bond. Okay, so here borazine does not contain banana bond, but they are saying it contains banana bond. It means this is the incorrect statement. What is our incorrect statement here? Option B will be our incorrect statement that we need to choose in the exam. Okay, yeah, so option B is perfect answer for this, and you can read other statements also. It can react with water. Yes, so borazine can react with water and forms orthoboric acid and ammonia gas is liberated. Okay, so what it is forming? So borazine B3N3H6 upon hydrolysis we will get orthoboric acid H3BO3 and ammonia gas is released. Okay, so remember this. Okay, what they are saying, yes, it can react with water. Next, it is a cyclic compound. Yes, it is a cyclic compound. So what is the incorrect option? Only option B is incorrect one that we need to choose as our answer, right? Yeah, hope it is clear. Let's move forward. Yeah, look at this, the geometry around the boron in the product B, okay, product B formed in the following reaction is, see, BF3 upon treating with sodium hydride. So what is a formed here? Okay, this A upon treating with trimethyl amine, okay, tertiary amine, we are going to get this B. So what is this B? In order to know B, first of all we need to know this A here. Okay, so boron trifluoride upon treating with sodium hydride, okay, it is a source of hydride ion. Okay, so now between these we are going to get at 450 Kelvin, we are going to get B2H6 as a product, B2H6, okay, and NAF. Okay, so these are formed here, 6 NAF is formed. I am not balancing the reaction here. Okay, anyways, our A is what? B2H6. Okay, this diboron having structure like this, just look at the structure here itself. I am going to give few questions on diboron next. Okay, so it will be having boron means BH3 unit like this. Okay, and we have diboron means 2 BH3 units are there. Okay, write it like this. And now if you look at like this, it has 3 sigma bonds and 1 vacant orbital here. Similarly to this also 1 vacant orbital is there. Okay, so since it has, if I consider only one fragment of BH3, so it will be having only 6 electron, which is electron deficient right now. So in order to stabilize the compound, they will dimerize. Okay, the like boron compounds will dimerize itself and exist in dimeric form by forming, see, these bonded, the sigma CH BH electrons will also be delocalized into here, and this this BH3 fragment electrons will delocalize here, or you can say they will be making a bond like B, okay, boron, two borons and hydrogens here, and in between that we are going to have a hydrogen here and one more hydrogen here, like this. Okay, something like this. The boron is having something like, if you consider one boron, you will be seeing some tetrahedral kind of structure. Okay, it means its hybridization is changed here. Okay, and you know there are 6 hydrogen atoms, but these terminal hydrogens are there now. So these are normal 2 center 2 electron bonds. Okay, so this between the 2 boron atoms we have hydrogens now. So these are BHB bridge bonds. BHB bridge bonds, we can also call them as banana bonds. What is that? Banana bonds. And these are electron deficient bonds because 3 centers are there, 2 borons and 1 hydrogen. So total 3 nucleus or 3 centers are there, but only we have 2 electrons. See, these bonded, these 2 electrons only spreading over 3 atoms. So 3 center 2 electron bonds. How many 3 center 2 electron? Above 1, below 1. So 2 3 center 2 electron bonds are there. Okay, and 4 2 center 2 electron bonds are there. Or they will ask how many tau bonds or how many banana bonds are present in diboron. How many? 2 are there. And you know, electron deficient bonds also we can be considered them. Okay, so now this is a electron deficient compound, this one diboron also. Okay, right now, so now when you treat this is this is our A. When you treat this diboron, this is the structures of diboron, this is the structure of diboron. Okay, so now whenever you treat this with N trimethyl amine. Okay, so now since it is electron deficient, the nitrogen atom can donate the lone pair electrons to that, so that it will breaks into single fragments and make a bond with each of this amine group. Okay, trimethyl amine. So you are going to get BH3 unit and one nitrogen having a day 2 bond with a boron, so forms like this. Okay, see what is the structure here we are going to get. So boron with 3 bonds here, hydrogen, and 1 bond from nitrogen of this trimethylamine. Okay, so total 4 sigma bonds are there now. So 4 sigma bonds means sp3. So if it is sp3 hybridized with 4 sigma bonds, the geometry or the structure will be tetrahedral. So what is the structure here? The geometry of the molecule formed here in this compound, the final product B will be having tetrahedral geometry. So that will be a perfect answer for the question, right? Yeah. Let's move forward with few more questions here. Yeah, we have a question from electrochemistry. Look at here, the time required in hours to reduce 3 mole of Fe+3 ion to Fe+2 ion. So I have Fe+3 ion. So the time required for reduction of +3 to +2 with 2 amperes of current is. Okay, so simple question. You can solve this question using Faraday's first law. So what we know, the weight of a substance deposited at an electrode is directly proportional to quantity of charge or current passed through the electrolytic solution. So from this, see, I can solve this within one step, but I just wanted to give you the steps, I mean complete concept here. So now this Q, the proportionality I can replace with electrochemical equivalent Z into Q means charge, I into T, current into time. Okay, we need to find this time here. So now what is this electrochemical equivalent? So Z is nothing but its equivalent weight divided by number of like Faraday here. Okay, so weight divided by weight here, equivalent weight by Faraday into I into T I am writing. So now weight by equivalent weight I can write weight by equivalent weight. Okay, equivalent weight and into Faradays. Okay, so if you write it like that, if you write it like this, it will be I into T now. So weight by equivalent weight means what? Number of gram equivalents. So number of gram equivalents, I can simply write N into N factor into Faradays equals to I into T. Okay, so now number of moles, how many moles given in the question? Just look at there, So 3 mole now, so you just take 3 mole. What is the n factor? See, plus 3 is converting into plus 2. It means number of electrons lost or gained. Here gained now. So how many electrons per atom? It is 1 electron. So n factor will be 1 into Faraday means what they have mentioned now. 1 Faraday is 96,500 coulomb. So 96,500 coulomb I am taking. And I just want this T, so I am sending this I here in the denominator. So I is how much they mentioned? So 2 amperes. 2 amperes. Okay. So now your answer will be time. Okay. But whatever you are solving here, that will be in terms of seconds. See, coulomb means what? Coulomb is nothing but 1 ampere into second. Right now, so I can write this coulomb as ampere into second. So now you can remove this, and by simplifying this you are going to get, see, second is there, but I want answer in hours, so I just divide this with 60 minutes and 60 seconds, so that we are going to get something like this. Okay, so by simplifying this you are going to get around 41.2 will be your answer. Okay, so 40.2 will be your answer for this particular question. Okay, so this will be in the hours, time should be in the hours here as per the question. Okay, so your option B will be perfect answer for this, right? Yeah. So someone in the comment box, Sirisha, hi sir. Yeah. Hi dear, just follow the class, and if you have anything to ask regarding the subject, you can ask me here. Okay, any doubts are there here? Yeah. So next, so take this question as a homework. So just try to find this number of Faradays required to completely deposit. See, always remember one trick here. So 1 Faraday is required for deposition of 1 GN of electrolytic solution. It means how can you find this number of gram equivalents? So just take it is n into n factor. So for this particular question, mg plus 2. Okay. So now it is given as 1 liter. So and 1 molar. So how can you relate GN? So normality is equals to number of GN by V. Okay, so GN will be equals to N into V. Okay, and normality is nothing but molarity into N factor into its volume. So volume is 1 liter and N factor for Mg plus 2 is 2 and molarity given as 0.1. So GN is equals to how much? So this is 0.2. Okay, so it means the number of gram equivalents here are 0.2. So number of Faradays will also be 0.2 because for 1 GN 1 Faraday is required. For 0.2 gram equivalents GNs we require 0.2 Faradays. That's it. That will be your answer. Option 2 will be your answer. Hope this is clear. Now see, I have given this complete information, a complete explanation for this. Just use this concept to solve this first question also. You can easily solve that. Right? Yeah. Next. So look at this, we have a question from organic here, no? Which are the following is metamer for the given compound? See, the given compound X and asking us to identify metamer for the given compound. So it is very easy, just tell me what is the definition of metamers first. So metamers means those isomers formed by which are differ in their alkyl group attached here. I mean, see here we have to the carbonyl group we have cyclohexyl group attached, and for nitrogen we have phenyl group attached. So now by exchanging these alkyl groups we are going to get a compound, right? So that compound is considered as the metamer of this particular X. Okay, so just try to interchange them. C double bond O, okay, attached with NH. Okay, okay, here NH, C double bond O, NH. Okay, so I am placing this cyclohexyl group on this nitrogen like this, and the phenyl group here on carbon like this. Okay, so now this compound is a metamer. This compound is metamer of this X compound. Okay, now choose the option which is having this kind of structure. Okay, yeah. So look at this. C, option C, no, option not C, option D you can see cyclohexyl here phenyl group is there and nitrogen, here cyclohexyl is there, and same phenyl group is interconverted here, so that you get option D as your answer. Very simple. See, this is JEE mains question asked in 2024. Right now you no need to waste even a single minute or single second for solving this kind of question. Just by looking at the question you can answer, right? Yeah. Now look at this, important this is. The total number of stereoisomers possible for given structure. Okay, so now see, first of all, how can you identify stereoisomers? So now look at here, how many stereo centers are there in the given compound that gives the stereoisomers possible. For example, what are stereoisomers? So stereoisomers can be of two types. Stereoisomers can be two types. One is geometrical isomers and another one is optical isomers. Okay, directly I can give the formula, just listen this concept also. So geometrical isomers means something like cis trans isomers, EZ isomers we are saying, and optical isomers comes from its chiral centers. Okay, chiral centers. Okay, so now geometrical isomers, see, where is this possible here? So look at here, is this a cis trans isomer? Can I say this is cis trans? No, right? Because here both are methyl groups only, so we cannot decide that. Okay, so we cannot say this is which is priority group here out of these two. So therefore there is no cis trans isomerism here or no geometrical isomerism here. Okay, and here if you observe what you have one carbon having three different groups like this. Okay, one hydrogen is there, one bromine is there, and one this big group is there this side. Okay, and this side bromine containing another double bond species is there. So now this, I can say this carbon is chiral center. Okay, so it means chiral center means carbon with four different groups. So this is one chiral center here I am highlighting, and you know, see here one group with respect to this double bond. See, one side is bromine, one side is methyl, and this side methyl, this side other alkyl group. So high priority groups are on same side, so you can say Z isomer. Okay, so how many chiral centers are there? It has two. So one is here. How many stereo centers are there? Two stereo center with one chiral center. Okay, so just take number of stereo center is equals to number of stereo centers are is equals to, take it as 2. Okay, so number of stereo isomers if they ask, number of stereo isomers if they ask, just simple, just take, if it is one chiral center, there are two isomers possible. Okay, one is R, another one is S. Similarly, if there is one stereo center like this geometrical isomerism, so there two, either E and Z are possible. So total take 2 power n. So where n represent number of stereo centers, that's it. So 2 power 2, your answer should be 4 here. Okay, your answer should be 4 here. Okay, and if in case here these two methyl groups are differ, for example this is one hydrogen, one methyl group is there, in that case you are going to get 2 power 3, so that will be answer 8, as because 3 stereo centers are there. Like that, very simple, you can easily solve this, right? Yeah, let me go with the next question here. Observe the structure of the following compounds. The total number of structures or compounds which possess asymmetric atoms is. So just identify which is having asymmetric center, asymmetric atom. Just now I told now asymmetric center is nothing but chiral center. Okay, so first compound here if you observe, you have 4 different groups, so it has one asymmetric center. Okay, and here there is no asymmetric center in this. Just identify carbon with 4 different groups, that you can say it is as asymmetric center or chiral center. So now here you have one asymmetric center, right? Yeah. So in this there is no asymmetric center, there is no geometrical isomerism or stereo isomerism, nothing. Optical isomerism, nothing is there here. Okay, and here you can see, here you have the total number of structures or compounds which possess asymmetric center. See, yeah, this compound possesses asymmetric center here, and it can also have asymmetric center here, and it can also have asymmetric center here. Okay, they are asking number of, they are not asking number of asymmetric centers in the all the compounds. They are asking how many compounds contain asymmetric center. So first compound and third compound and fifth one. So only 3 compounds contain asymmetric center. So in the fifth compound, how many asymmetric center? If I ask what is your answer, your answer should be also 3, as here one and here. Right? Is this clear? Right. If it is clear, just click on the like button. Okay, and let's move for the one more question here we have is, the decreasing order of hydride affinity of the following carbocations is. So it means which compound is having more affinity, that comes first, and which is having less affinity towards hydride comes last. It means these are carbocations, right now. So carbocations are intermediates during the chemical reactions. Okay. So now if the carbocation is very unstable, then it has more tendency or more affinity towards the nucleophiles like hydride ions. Okay, which is least stable out of these four, that has more affinity to accept the hydride ion. So tell me, first of all you need to know the stability order here. Okay, so if you consider the highest stable carbocation here is the option, it is exceptionally stable because of the cyclopropyl here group here is there now like this. So these bonds will participate in conjugation like this with the carbocation. So like this, from here, from this bond, and from here, and also from this side, and from this side. This is very effective stabilization. Okay, therefore which is highly stable, D is highly stable, therefore it has least affinity towards hydride ion. So which is having least affinity, D. Okay, next. Okay, next what I can say, this is more stable, so least affinity towards hydride ion. Okay, next, out of this remaining A, B, C, if you look here we have triphenyl groups and here we have one allylic carbocation. So we know phenyl carbocations are more stable than this allylic carbocation. So I can say this will be more stabilized after D, therefore this will be having less affinity when I compare with A and C. So I am writing here less affinity for B. Okay, now look at the stability of these two things. Now see, allylic, this side it can be stabilized by allylic carbocation. Okay, and this side we have two alpha methyl groups. Okay, it means hyperconjugation is there from the 6th position, 6 alpha hydrogens, and here it is having alpha hydrogens. Okay, with 9 alpha hydrogens, this can be stabilized by hyperconjugation, and it is also stabilized by hyperconjugation along with the mesomeric effect. So this will be more prominent effect to stabilize the carbocation. Therefore this will be more stabilized carbocation than C. I can say this is more stabilized, so less affinity towards hydride ion. So I am writing here A, and more affinity is for C, right? So this will be the order for this particular question. So now look at the question, look at the options which are having this kind of answer. See, option B, C, A, B, D. So option B will be your answer for the question. Hope this is also clear, right? Let us move forward. Now look at this, the major product of P formed in the below reaction is, see, we have this substrate upon treating with HgOAc twice followed by hydrolysis, treating this with the sodium borohydride. This is called OM-DM reaction, oxymercuration and demercuration reaction. So what happens here is, so first of all this mercury will be forming a 3-member cyclic ring here as an electrophile. Okay, after formation of this HgOAc 3-member cyclic ring. Okay, so now the attacking of this water as nucleophile takes place, but where it attacks, see, the water attacks takes place following Markovnikov rule addition. It means what? It should go and attack at those carbon site which, or you can say just attack this wherever there is more stable carbocation. See, if I open this ring, 3-member ring at here, you are going to get a tertiary carbocation which is more stable. But if I open this ring, 3-member ring at this carbon, terminal carbon, which is the relatively least stable, right now primary. So that's why the attack of water takes place at this tertiary carbon of this 3-member ring. Therefore you are going to get something like this, CH2OHG OAC, and here you can have OH. Okay, so now if you treat this with NaBH4, what happens is, so this is a demercurating agent, removes this HgOAc and gives us a product like this, OH CH3, that's it. So this will be your perfect answer. So where do we have? So option C is your answer for this question, right? Yeah, I hope this is also clear. Yeah, if these things are clear, just click on the like button. And guys, if you are new to our channel, just subscribe the channel first so that you will get updates from us, and you can also be updated with our daily class schedules and everything. Okay, yeah, let us move forward. Okay, so match the following here. List 1, list 2 are given. So what is Lucas reagent? So it is anhydrous ZnCl2 and concentrated HCl is considered as Lucas reagent. So what is the use of this Lucas reagent? So it will be used for conversion of alcohols to alkyl halides, like for example alkyl chlorides here I can say. Okay, and you know what is the reactivity of alcohols with this Lucas reagent is one of the very important question that you can come across if you look at any paper. So which are the following react more readily with the Lucas reagent, they will ask. So always remember tertiary alcohol more reactive than secondary and primary. Okay, so because respective carbocations are more stable in tertiary alcohol, that will makes it more reactive. Okay, yes. So and it follows most generally it follows SN1 reaction mechanism. Okay, next Tollens reagent. So Tollens reagent here is ammonical silver nitrate solution is called Tollens reagent. Okay, so use it to identification of aldehydes, like all type of aldehydes like aliphatic, aromatic aldehydes. Whenever you treat with Tollens reagent, converts into oxidized form, like carboxylic acid is formed, which is showing a silver mirror due to the presence of silver atoms here. Okay, so that precipitate or that whatever the test tube you are looking for, I mean you are identifying here there, so you are going to get a silver mirror at the top. So that indicates the given compound contains aldehydes. Okay, it is given only by aldehydes, not by the ketones, remember that. Okay, and Clemmensen reduction. So Clemmensen reduction here, so like zinc amalgamine concentrated HCl here. Okay, so what is the use of this zinc amalgamine concentrated HCl in the Clemmensen reduction is they converts carbonyl compounds like ketones, aldehydes to respective alkanes. Okay, so this kind of conversion C double bond O converts into CH2 group. So methylene group comes in the place of this C double bond O. Okay, so this is a conversion taking place in Clemmensen reaction. Okay, Clemmensen reduction, that's it. Okay, what about Stephens reduction? So Stephens reduction here SnCl2 and HCl dot H3O. So this will be the reagent for Stephens reduction. And if you look here, you have benzene sulfonyl chloride. So this is for Hinsberg test, Hinsberg test or Hinsberg reagent, that is used for distinguishing of amines. Okay, like primary, secondary, tertiary amines. So this is not there. So just remove this and remaining options you can match. A3 here and here, that's it. And the next Clemmensen reduction is 4, yes, here and here. And next Tollens reagent is 2. So here first option will be your answer for this particular question, right? Hope this is also clear, right? Okay, let's move forward. Yeah, so this is about the session, and you know I just wanted to ask you few questions based on the Tollens reagent. So which are the following gives silver mirror test? Okay, so write the options. And yeah, so this is a simple question I can make asking about which are the following compounds will give silver mirror test. So I want answer for this particular question in the comment box. So just try to mention which of them will give. Like if option A gives, you mention option A for silver mirror test. Along with this silver mirror test, I may also asking and also answer which of the following gives silver mirror test, I can say, or Tollens test. And one more we have Fehling's test. Fehling's test. So just write in the comment box, mention silver mirror test and mention the options that will gives you silver mirror test from these 5 options. Okay, and also next mention Fehling's test and the represent the options which gives Fehling's test. Hope the question, you can easily solve this particular question, and hope you enjoyed the session and you have learned something new. And if you are really new to this channel or are really planning to like prepare for your JEE, NEET or EAPCET entrance exams, so just click on the subscribe button, and if you wanted to join with us, just contact to the mobile numbers given in the like description box, and you can join our Telegram group for daily questions, practice papers, or anything that you are like looking for. Okay, I mean for any doubt session, or if you wanted to ask some particular things separately, just post it in the Telegram group of this NEET World channel, so that our team will update you regarding that. Okay, thank you for watching. Stay connected with us.